To be or not to be a function, you will be able to determine if a relationship between two quantities is a function by using the definition or vertical line test. So the definition for a function is a relationship where each x input has only one unique y output. So to put that into a little perspective, here is a table, and here are some coordinates. So we'll start with 0, 1, 2. So in this case, each of these x inputs will have a distinct y output. So now let's look at a relationship that is not a function. See if we can tell the difference. So we can have my x and y coordinates. So here, notice that I have the same x. But now look what happens when I have my y. This same x coordinate should give me the exact same y. So if x is 1 and y is 3 here, then x should be 1 and y should be 3 there, but it's not. So in this instance, our definition does not hold true. In this case, each x input gave us 2 different y outputs. So that would be a function. So the thing to look for here is whenever x is the same number, it better have the same y output. If it doesn't, it's not a function. Now, we also have a vertical line test we can use on the graph. Let's go ahead, put this graph out here. So if I draw a line to determine if that's a function, we're going to actually use a vertical line as a tool. So you could use the edge of your piece of paper, you could use your pencil, you could use your finger, a ruler. If this vertical line crosses my graph at more than one point, then it's not a function. So notice it crosses here, it crosses here, it crosses here, it crosses here, it crosses here. So at nowhere on this graph does this vertical line cross at more than one point. So this is a function. How about if I give you a quadratic function where we have a curve? So here's my...
Mr. Clark, please call the office.
There's my relationship there. So now if I grab this vertical line, again, nowhere on this graph does this vertical line touch the graph at more than one point. So that's a function as well. But look what happens if I go ahead and turn this. So now my relationship goes that way. Well, notice here I'm crossing and here I'm crossing. So that suddenly makes it not a function. If we were to actually identify these points, let's say here and here, this is what it would look like on the function table. So I'm going over 2 and up 7. And I'm going over 2, and you would expect this to be 7 again, but this time it's -5. So for every x input, I should have a unique y. But in this case, I have 2 of them. So that's, again, why it's not a function. So let's go ahead and do a few examples. There's your function table. 1, 3, 7, 9, -4, -6, 7, 2. All right. Now some kids look at this and say, well, there's no pattern here. They're kind of looking at slope. That's not the definition. The definition is for each x input, there should be a unique y. Since none of these x's duplicates, then we don't have to worry about the y's over here. So this is going to make a function. If I go ahead and graph this, it's not going to make a straight line, which is okay, but it will still pass the vertical line test. So I have 1, -4, I have 3, -6, I have 7, 7, so I'm going up here, and I have 9, 2. So notice what my function does. It goes here, then jumps up there, and then here. So it's not a linear function. It's not a quadratic function, but notice it does pass the vertical line test. Nowhere on my graph does it cross the x-axis or intersect the x-axis more than once. Okay? All right, how about this graph? What if I do this circle? Let's make it, okay? I don't like that. Let's actually make a line. All right. Well, we could go ahead and pick points on here and make a table, but we also know on a graph that we can use our vertical line test. So if I draw this across, does it cross my graph anywhere more than 2 places? And of course it does. Here and here, for example. Now a student said today, well, what happens if the line doesn't actually cross like this? Well, in this case, remember, this vertical line goes on forever. So even though it doesn't look like it crosses on my graph, I could extend it, and now it would. Okay? Okay, how about this one? Is that a function? We know it's not a linear function because it doesn't make a line, but let's use our vertical line test. Does it cross at more than 1 point? So no. As you draw this across, it never crosses at more than 1 point. So yes, this is a function. One more. Let's do a table. About -1, 0, 1, 2, 2, and then 3, 6, 7, 8, 9. Well, the first thing you should notice, I have x twice. So we know for each x input there should be a unique y. Well, each of these 2's then should give me the same y, and of course, they don't. They give me different y's. So we know this isn't a function. And to prove that on our graph, let's go ahead and plot these points. So I'm at 1, -1, +3, 0, 6, 1, 7, 2, 8, and then notice 2, 9. So if I go ahead and connect these now, my graph looks like this, and suddenly the 1 is right above the other. So if I move that over properly. So if I went to do my vertical line test, anytime I have a vertical line going up and down, I'm going to obviously cross it more than one place. So notice both of these right there cross on that vertical line. So that will be not a function. And of course, we knew that from our function table. So here are just a few examples. So now make sure you do your Edmodo quiz to get credit.